Okay, back page of this. Again, we're finding the roots, so I first need to draw the picture of where is 1 in the real part, radical 3 in the imaginary part, so I can find my r and my theta. So z to the third is going to have an r value. If I take square root of 3 squared plus 1 squared, I get 4, so r is going to be 2. The angle of z to the third, again, if this is 2, my cosine is 1/2, my sine is radical 3 over 2, so that happens at pi over 3. So there's the original z to the third. So now to find my 3 roots, I'm going to take 2, and I'm going to take the cubed root of 2, so I either, again, can write it as the cubed root of 2, or I can write it as 2 to the 1/3. They both mean the same thing. And then my angle, my first angle is going to be my original angle pi over 3, but I need to divide that by 3. So if I take pi over 3 and divide it by 3, I multiply by 3 over 3, I get pi over 9. So the first angle is pi over 9i. What do I need to add each time? I need to add 2 pi over 3. To get around the circle in equal parts, I have to take 2 pi, the whole circle, divided by 3. So I need to take pi over 9 and add 2 pi over 3. 2 pi over 3 is really 6 pi over 9, plus pi over 9 is 7 pi over 9. And if I have 7 pi over 9 and I add another 6 pi over 9, I get 13 pi over 9. And this is all the exponent. This e should probably be a little bit bigger. So it's e raised to that power, just to make sure you know that those are exponents there. If I added another 6 pi over 9, I'd be at 19 pi over 9, which would get me back to here, so I don't have to do that. Okay, so those are my 3 answers. My radius is 2 raised to the 1/3. I have an angle of pi over 9, 7 pi over 9, and 13 pi over 9. To graph it, we can graph it real quick. There's pi over 9. 7 pi over 9 would be over here. And 13 pi over 9, this would be 13.5 pi, so it would be a little bit less than that. So those are my 3 roots. All right, let's try this one, just I. So it really means I have 0 plus 1i. That's what z to the 4th is. My real part is 0. My imaginary part is 1. And so that has a radius of 1 and a theta of pi over 2. So z to the 4th in exponential form is 1 e to the pi over 2i. All right, so I need to find the 4th root. Well, I have to take the 4th root of 1. Well, what times itself 4 times gives me 1 is 1. So of my 4 answers, my radius is going to be the 4th root of 1, which is 1. You don't have to put the 1 there, but you definitely can. And then I need to take my original angle and divide it by 4. So if I take pi over 2 and divide it by 4, I'm going to get pi over 8. So pi over 8i. And then I need to decide, what do I need to add to that each time? I need to add 2 pi over 4. I need 4 answers. And since I'm in 8s, I have to think about what would that be in 8s. It's going to be 4 pi over 8. So if I have pi over 8, add 4 pi over 8, I'm at 5 pi over 8. And then if I add another 4 pi over 8, I'm at 9 pi over 8. And add another 4 pi over 8, I'm at 13 pi over 8. And those are my answers. So my radius is 1. My angles are pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. Okay? All right, and then the last one. Last one I tricked you a little bit. This is in rectangular form, but it's not simplified. So what I would probably do first, different ways we can do this, but I would probably first multiply by the conjugate of that denominator so that we can rationalize the denominator. So I'm going to get 2i minus 2i squared over, when I multiply these out, I'm going to get 1 minus I squared. Because remember, that middle term is going to drop out 1i and negative 1i. And remember, I squared is -1, so this is -2 times -1. It's going to be 2. This piece will be real, it'll be positive 2 plus 2i over 1 plus 1, because I'm taking -1 times -1. 1 plus 1 is 2. So it simplifies to 1 plus I. So now I know z to the 6th is 1 plus I, which is 1 over and 1 up, which means z to the 6th has a radius of square root of 2, so I'm going to say 2 to the 1/2, and my angle is pi over 4. So that's z to the 6th, 2 to the 1/2, and then e raised to the pi over 4. All right, and then I need to find the 6th root, so I need 6 answers. So I have to go from z to the 0 all the way to z to the 5th. My first one is going to be 2 to the 1/2, my original radius, raised to the 1/6 power. So if I have 2 to the 1/2, I'm going to raise it to the 1/6. I'm going to get 2 to the 12th power, or the 12th root of 2. So all of these have the same radius, the 12th root of 2, or 2 to the 1/12. All 6 answers. So that's the radius. The first angle, I'm going to take pi over 4, and I'm going to divide it by 6. So when I take pi over 4, divide it by 6, I'm going to get pi over 24. That's my first angle, pi over 24. What am I going to add? I'm going to add 2 pi divided by 6, or pi over 3. Now, I'm in 24ths, so how many 24ths would that be? 8 24ths. So I start with pi over 24. If I add 8 24ths, that puts me at 9 pi over 24. That reduces, 3 goes into each, so 3 pi over 8. And if I'm at 9, I add another 8 pi over 24. I'm at 17 pi over 24. That one doesn't reduce. I'm at 17, and I add another pi over 8. I get 25 pi over 24. And I add another 8. I'm going to get 33 pi over 24, but that reduces. Again, 3 goes into each. So it'd be 11 pi over 8. And if I'm at 33 and I add another 8, that would be at 41 pi over 24. So I think I got them all. Again, my radius is 2 to the 1/12th power. And then I start out with pi over 24, and then I keep adding 8 pi over 24. So I get 9 pi over 24, which reduces, 17 pi over 24, 25 pi over 24, 33 pi over 24 that reduces, and 41 pi over 24. So when I go to graph those, I kind of forgot to graph the last one, I guess. When I graph those, I should have 6 of them equally spaced apart. So at pi over 24, I'm here. 3 pi over 8, I'm here. 17 pi over 24, this would be 24 pi over 24, so it's up here. And then these will end up just being opposite of each other because they should be equally spaced apart. So, oh, that's bad. But there should be 6 of them and somewhat equally spaced apart. That if you connected them, which mine doesn't look very good, you should have a regular hexagon when you're done. Okay, so those points, these points are the numbers you're looking at with those radius and betas. Okay, so that ends the back page of the worksheet on roots.